Hi, I'm Kevin Jones. I'd like to talk with you today about some ideas that are getting a lot more attention recently, especially a couple images that I've created that are getting out there a lot more. These concepts are really important for manufacturing, and I thought it worth doing yet another video to help get these ideas across, help people understand what's going on. And we'll also talk about some specific products that kind of follow some of these philosophies and technology rules that we use and make sense to use in our Industry 4.0 solutions. So I'm going to get right to it. The idea here is to talk about Industry 4.0 and the approach that you can use to get real-time visibility into the factory floor, into the plant floor. As a bit of background, we're a manufacturing industrial intelligence solutions company, and our focus is to help companies operate more efficiently and grow, and do that using open technology solutions, flexible, scalable, affordable solutions, following the basic principles and ideas from Industry 4.0, 4.0 solutions, etc. To set the framework or frame of mind, let's talk a little bit about manufacturing. Manufacturing is getting to be a lot more difficult these days, especially with what's going on in the economy. At the big perspective, labor challenges, inflation, supply chain, etc. And also there's still those kinds of problems in the plant. Companies still have machine downtime, production throughput, quality, etc. It's tough to be a manufacturer, there's no doubt about it. But the question is, how do companies try to solve these challenges? How do you actually figure out what's going on and solve? The idea is to get data, get that real-time visibility into factory floor, understand what's going on right at the factory floor. However, a lot of companies are still focused on the ERP system being the center of their world, and the ERP system providing, in their minds, most, if not all, of the valuable data. They have a lot of other systems, and some companies are realizing that they can integrate with these systems, but often enough, over time, manufacturers have created discrete connections between these systems. Those discrete connections can be very expensive. They're difficult to maintain. They're sometimes hard to set up. And if you were to swap a system out, remove one system and replace it with something else, what are you going to have to do? You're going to have to reestablish all those discrete connections. Doesn't make a lot of sense at all. And one of the other challenges that we see in manufacturing is, again, ERP system is the main system of the plant. And that ERP system is up here at the top of the company. And then you have the factory floor down here. ERP systems are doing the supply chain, orders, inventory, scheduling, sometimes doing the scheduling well, sometimes not, accounting, etc. But then at the factory floor, you have the people and the machines. How do they understand what they need to be working on and priorities? How do they analyze the problems they have on the factory floor? How do they get data back up to the ERP system and to other parts of the organization to understand what's going on? Usually that big space between the ERP system and the factory floor is a big blank space filled with pieces of paper and spreadsheets. And pieces of paper and spreadsheets, for as nice and cheap as they are, aren't a very good way to get that real-time visibility into what's going on and share that information across the organization. So the idea is, let's actually try to achieve a higher status, a higher capability. Let's connect everyone and everything into a network. And then let's get everybody at all layers of the organization to understand what's going on in real time. And then at that point, the stakeholders of the organization know in real time what's going on right now, and also they will have data to know what's going on in the future, eventually getting into artificial intelligence and machine learning and other ideas and technologies. At this point, if you've connected everything and everybody knows what's going on, then you'll have access to the data. What you're really doing is becoming a data-driven organization, or you're getting into data-driven manufacturing. For us, the definition of becoming a data-driven organization is that you have a single version of the truth, all of the data in one central place, and people have the tools to be able to get that data. They'll have broad access to that data generally. They'll understand how to use it, and most importantly, they are enabled to make decisions and take action based on that data. So becoming a data-driven manufacturer is really kind of the holy grail here. That's the ideal state to achieve. But we don't want to try to achieve it, or can't really successfully and easily and affordably achieve it by creating a setup like this with the ERP system at the center and all these discrete connections. There's so much data on the plant floor that the companies generate every day but don't have access to. And ERP systems are not good for that kind of data, to work with that kind of data. They're very transactional systems. So you should be using the right tool for the right job. So let's take a look at how things could potentially work. An alternative is to move over to some ideas that we like to talk about. Using a data clearinghouse or data broker. I often refer to it as the Grand Central Station, or depending on what city in, the Union Station, train station of the city you live in. Or let's call it a hub and spoke architecture. Data, all the systems go to a central system, this data broker in the middle. And then any system that wants to get data will connect to that system and pull the data from that central system. Any data that wants to push data in and provide it to anybody else, they must push that data or publish that data into that central system. With this kind of idea, then, all systems are connecting to one central data broker, and there are no discrete connections, or virtually no discrete connections at that point. This enables you to eliminate the difficulties, challenges, and expense with those discrete connections, and allows for data to be shared in real time across the organization. Now, keep in mind, you don't have to attach or connect all of your systems all at once in one big project. This is something that you can execute over time. You can peel back the layers and pull off one application from those discrete connections, and one at a time, or even little bits of data at a time, connect them to the central data broker, and then over time disassemble that spaghetti mess of connections you have and create a more centralized system like this. But one of the critical elements of making this kind of system work is not only using that hub and spoke idea to provide that single place where data can be accessed, but is also to use the idea of unified namespace. The idea of unified namespace, really developed through Walker Reynolds and 4.0 Solutions and some other people. And so what we mean when we talk about unified namespace is to use kind of a tree leaf way to organize the data. Here it's enterprise, site, area, line, and cell. So that if you were to structure your data for any data that gets into the data broker, that data will, for that PLC or for the MES, depending on where that PLC is at, or what plant or what area that MES is addressing for its data, that data will be slotted into the right enterprise, the right site, the right area, and then any other system across the organization can go immediately to that namespace, if you will, to find that data, consume it, or to publish its own data. So as an example, let's say that we have Coca-Cola Enterprise, and then we have a plant in Pittsburgh, our hometown here, and then we have a bottling area, and then we have the line 1 for bottling, and then we have a PLC, the PLC 1 for that bottling area. At that point, then we would list all the tags for that PLC under that system. But this isn't about just listing machine data, process data, tags for machines, but also to enable us to see data for other systems too. Let's say that we want to be measuring OEE and downtime for that line, and be able to have access to ERP data for that location, for the Pittsburgh location. Then we can fit that data into the structure as well, so that anybody and everybody can find it. And you would actually see in some of the tools, in just a few minutes here, you would actually see the data in that tree leaf kind of structure. It's very similar to if you're using Microsoft Windows or other operating systems and you want to explore the structure of your folders on your computer. Most of those Windows Explorers or File Explorer tools will show a folder, and you press a little star or arrow or triangle next to the folder, and it drops down and indents and shows you some other folders and files under that folder. And then you click the arrow next to one of those folders, indents, drops down, and you see other files and folders. It's the same kind of idea. Literally, it's the same kind of idea. So again, the idea of using this data broker, this hub spoke structure for data and pushing everything out to a node on that in that ecosystem, including the ERP system. I know that ERP companies and IT people that are heavily involved with their ERP systems might not like being put off to the side, so to speak, but the ERP system is just as important as every other node in that ecosystem to provide and consume data. So once you've put that data clearinghouse at the middle where the data passes through, all systems are connecting to the data clearinghouse, and you're structuring the data, at that point you've been able to achieve a very flexible and scalable solution. There are a lot of other ideas that we use within this, which we talk about in other videos, including the idea of establishing a digital strategy as you are looking at transforming to become a data-driven manufacturer. That process of transforming is often referred to as a digital transformation. And the idea is to create a digital strategy from leadership that defines how the fact that the company recognizes the value of the data, and also that the company recognizes how they're going to utilize the value of that data throughout the organization. The idea is also to establish other rules for selecting technologies and principles and philosophies for how you're going to execute projects. Again, ideas are in some other videos, such that you are then defining yourself, you're defining some guardrails for yourself throughout the digital transformation. These guardrails will enable you to limit and control your decisions within a good space to make sure that you're selecting technologies that are edge-driven, lightweight, report by exception, and also open technology. And the open technology is the one I want to focus on here. The idea of open technology solutions is that you can, with each of the technologies you choose, whether it's a data protocol, an architecture, a software product, or a hardware product, that system will provide access to its data to any other system, and that system can consume data from any other system. You know what that means? That means no proprietary systems, no lockdown of protocols, no lockdown of data, unless you pay an arm and a leg, unless you pay some extreme amount of money to have access to that data. There are a lot of companies out there that unfortunately are trying to contain their data within their system, and they have the highest ideals in doing so. But what it does is it locks that company into that vendor. It becomes a finger puzzle. You stick your finger in and you can't get it out. So we like to be very agnostic about the technologies we choose, and use a more open architecture and also this idea of open technologies. Once you're able to share the data across the organization because you've connected everyone and everything to the network, and you've used an architecture like this that's much more flexible, then at that point the organization can move from mostly firefighting to really starting to innovate. You're sharing the data with the people on the plant floor. Those are the people that are most valuable in the organization because, let's be real, manufacturing doesn't exist without the machines and the people on the plant floor. They need to be a part of the discussion. Operations, OT, need to be a part of the discussion and have access to the data. It's not just IT's realm. So, with that in mind, let's talk about what pilot projects typically look like. We'll often start off with 1 or 2 or 3 machines or an existing system that is in place. And this represents a couple situations that we're looking at right now. So let's say we're looking at a particular machine that might have an Allen Bradley or a Siemens PLC. In this example, we'll talk about Siemens because we have that later on here. And also let's look at the Werma system, Andon lights and other products, along with its SmartMONITOR software system and the database on the back end. It's a nice system, similar to others we've seen out there, and seems to work really well in practice because we've been running into it more and more. Andon lights, interchangeable, radio signals communicate to a central system. The lights can be programmed, can be connected to the hardware or the equipment, and signal any number of things with the different colors and different flashes and all the rest of that. And then with radio signals communicate to a central system. And then the Werma SmartMONITOR software captures that data, stores it, and displays it. Quite honestly, very often we're doing that using tools like inductive automation or the inductive automation ignition software or Tatsoft's FactoryStudio software. But just because we have the ability to use those tools to create solutions doesn't mean that we always need to use them. We can use other software systems out there that are already collecting data. This is the idea of open technology. If that system provides the data in an open way such that we can get it and share that data and use it in the rest of the IoT ecosystem, then at that point, let's work with the product. And Werma's SmartMONITOR, as an example, actually provides access to the database. They don't have an API, they don't have a few other things, but they at least provide access to the database. So what we've done, we're actually doing this now, is pulling data from the SmartMONITOR, and then the Siemens PLC is connected to a gateway device like an Opto22 Groove Epic Smart PLC, runs Linux and has extraordinary capabilities, with the Inductive Automation Ignition Edge product running on that Groove device because it has Linux and is an open technology hardware device and software. Then we're able to convert that data from the Siemens PLC, probably OPC UA in this instance, convert it to MQTT Sparkplug B, publish that data into the data broker, and in the PLC or the Groove device, we're setting up that data, structuring it with the unified namespace, such that when it arrives in the HiveMQ data broker, then that data is structured and ready to be consumed. Same thing happens with the Werma SmartMONITOR. That data can be gathered from those machines through this software system, or pulling the data from the database, then publishing that data to the HiveMQ data broker. And then at that point, once the data is in the data broker, any other system, like a SCADA system, MES system, a Historian, like the Canary Labs Historian product with their Axiom visualization tool, they can subscribe to that data, store it, visualize it, analyze it, and potentially even publish that data back into the system. As an example, very quickly, let's say that we wanted to calculate OEE. The PLCs could publish data into the data broker. The CMMS or maintenance system could publish some planned downtime into the data broker. The MES system could subscribe to that data, pull it all in, do the basic arithmetic calculations to calculate OEE, display it on a screen, maybe store it, and then, if it wanted to, publish that data back into the unified namespace here, and enable that data to be pulled by maybe a business intelligence tool, so that the people in the carpeted office or at the enterprise or headquarters level can see the trend charts for where hopefully OEE is going up over time. Once that pilot project is proven to be successful and people who have worked with us as a systems integrator to implement those kinds of solutions, once they're actually starting to get success and build political capital internal to the organization, then the idea is to figure out what we've all learned from that, from the machines, the manufacturing processes, opportunities for improvements and efficiencies, etc., and then start to scale it out. So let's say that we then start to add more machines, pumps, presses, motors, other machines to the Werma monitoring system. Maybe we're using Tatsoft FactoryStudio to develop the MES system. We're using Canary as the Historian, and maybe we're even integrating with the eMaint as the CMMS and Infor Sightline as an example of an ERP system that we could certainly integrate with, because it has APIs that we can communicate with, and so does eMaint, by the way. Once the data is structured and available in the data broker, again, data can be consumed by any other device, and that data is now being people across the organization, at all levels of the organization, will have visibility into the data that they need. At that point, because of the way data brokers work, it's a straightforward process to set up another data broker in another part of the organization, say at the enterprise or headquarters level. And then at that point, the data broker at the plant level can communicate directly and immediately with the data broker at the enterprise level, and immediately the data is available at the enterprise level. And the same thing goes for the plants as well. Just a real quick bottling line example. We have a PLC, it's not live here right now, but we have a PLC and a system set up to operate what is effectively a capping line. And let's say that we're pulling data from that capping line, these various tags here. I'll go through just a few screens to give you an idea of how this connectivity process works. So at a high level, quick review, we'd connect the PLC to the PLC, identify the registers, then convert them into tags. We'll connect the PLC to the data broker, publish the data to the data broker from the PLC. The tags will then be structured and pushed into the data broker within the unified namespace structure. Then Ignition as an MES system and potentially Canary as a historian will subscribe to that data and pull the data and use it to do whatever they're doing, storing and analyzing the data, etc. So that first step, again, we have a quick view of TIA Portal, the Siemens TIA Portal software for working with PLCs and developing your solutions. This is what it looks like when you're looking at the tags. Then we have to set up the data broker to connect the data broker to the Ignition, or excuse me, we're going to connect the Siemens PLC to the Ignition database. These are the screens within Ignition to do this. We'll set up the connection to the data broker, specifically HiveMQ in this instance, and the Ignition engine. We'll publish the data to the data broker at that point and into the unified namespace. And at that point, the next step is to, well, here we'll be able to see in the, what tool is this? This is Ignition. We'll be able to see the data in the UNS or Unified Namespace structure here. And here we're pretending as though we have an enterprise called Big Name Brewing, and there's a location for a city that's close by here called New Kensington. Then there's an area of that brewery called packaging, and then we have line 1 within that, and then we have a PLC for the capper, and then all of the data that's available under that capper. Keep in mind, again, we're not talking only about tags for the capper and the piece of equipment itself, but also calculated values that we've calculated maybe internally or have pushed out and pulled back in for this capper device or piece of equipment. Once we have data in that data broker, then we can set up Inductive Automation's Ignition product and start to develop a very basic MES system. It will subscribe to that data, and now we can calculate and display OEE, schedule information, etc. And you can see here we're running an IPA, an India Pale Ale product, with the in-feed, out-feed, scrap numbers, run time versus the elapsed time, etc. And then we can also develop a screen to show downtime in the Ignition Designer. All of these screens that we're seeing here are the Ignition Designer screens. And we can also get a quick view of what the data looks like in the Canary Historian as well. This is the Axiom Data Visualization Tool, which is a really nice, very easy to work with visualization tool. Easy to set up. Once you have the tags in, organized using define the asset models, etc., then you can very quickly add symbols or objects to the screens, tie them to certain tags, and display the data as needed. That's the whole idea I wanted to go through, which was really to talk about the idea of companies becoming data-driven organizations and being able to set up flexible, scalable solutions using these open architecture ideas with data brokers and unified namespace. I hope this was valuable to you. Please subscribe to our YouTube channel, and we'll see you again on another video.